Everyone, today let's go over a medium question that I just solved on my own. I'm really proud because I struggled with this one for a very long time, for over half a year, and I came back to it and I was able to solve it with the new techniques that I've learned this month, so really happy about that. So this one's called Sliding Subarray Beauty, and it has a pretty low acceptance rate if you don't know how to do it efficiently, but I'll show you my own way of doing it that I came up with. So you're given an integer array nums, and you want to find the beauty of each subarray of size k. So right away, you can see that this is a fixed length sliding window problem. So we're going to find all subarrays of length k first. That's the first step. And then you have some things you need to do to get the result. So the beauty of the subarray is the x smallest integer in the subarray if it's negative, or 0 if there are fewer than x negative integers. Basically, if the subarray of size k has less than x frequency of negative integers, then you append 0. Otherwise, append the x smallest integer. So in this case, the x smallest integer, because there are three negative integers, that is not less than x, which is 2. So then we're going to append -2 because that's the x smallest one. So second smallest one, first smallest one is -3, second smallest one is -2. And then we keep doing that for every subarray of size k. Here, again, there are two negatives. 2 is not less than 2. It has to be strictly fewer than x. Then in this case, again, we're going to append -2 because that's the second smallest one. So let's go ahead and first come up with a brute force approach. So to get every subarray of size k first, we're going to return a list. So let's go ahead and define that. Let's go ahead and iterate over the array to get every subarray of size k. Print subarray. So I submitted a little too much, but here you can see this is every subarray of size k. And now let's try to determine the count, how many numbers in this subarray are less than 0. So for C in count, or S in subarray, if S is less than 0, then count plus equal to 1, right? Because that's another negative we're seeing. If count is, let's say, bigger than or equal to x, then we can get the x smallest integer, right? So let's set this flag to true because this is determining whether or not there are fewer or less than x, not k. And then let's break it. At the end, if the flag is true, then there are bigger than or equal to x. So we want to get, let's call this A equals to sorted list of subarray. There's more than x or bigger than or equal to x, then we want to append A of x minus 1 because that's going to give us the x smallest. So for example, here we have -3, -2, -1. X is 2, so 2 minus 1 is 1 for this subarray right here. Otherwise, if flag is false, then result.append 0. And you can just go ahead and return the result after you evaluate each subarray of length k. So while this technically works, it's going to time out. So, okay, so, oops, this is not right. Let's see. So the count, yep. If flag is true, then we have bigger than or equal to x, right? Oh, we don't need a break here because maybe the false will affect the solution too. So, okay, that should work because just because you're seeing true once doesn't mean that the rest, or maybe there's a bug here. Let's see. Okay, anyways, let's just say at the end, if the count is bigger than or equal to x, right? So if s, this number in the subarray, is less than 0, count is plus equal to 1. If count is bigger than or equal to x, then we have to append the x smallest integer. So result, okay, this sorted list subarray result.append a of x minus 1, else result.append 0. This should work because this is the brute force way. There we go. So time limit exceeded, right? I don't know what's going on with that whole flag system, but this is the brute force, time limit exceeded. So instead of this is n squared, let's come up with a better solution using a sorted list. Let's call this SL. Let's do sorted list, and we're going to get every size of k that's already sorted. So let's first start with nums of up to k. Let's print SL. We can get rid of this for now. So, okay, so we got the first 3 in sorted order. Great. So now the results still the same. We need to find how many negatives are in this list quickly without iterating over the whole thing. It's already in sorted order, so we can bisect left inside of this sorted list is 0. Why? Because if 0 is here, then the bisect left will give you 2. Bisect left will give you, if you do 0, because 0 is not positive or negative, it's going to give you exactly how many negative elements are in the sorted list. So let's print B just to show you. So 2 negative elements in the sorted list, right? Because 0 goes here at index 2. So then, in this case, if, let's say B is what? If B is bigger than or equal to x, right, then we can append SL of B minus 1, because let's say we want the second one, then we're going to get the first index, 2 minus 1 is 1, 0, 1, right? Because it's already in sorted order from least to greatest. Otherwise, result.append 0. And then we want to do this for all the other windows as well. So again, length of nums minus k. And let's print I and then I plus k, because we want to see which ones we're going to remove. Okay, so now if we're starting with size 3, we want to get this window. What do? Well, we get rid of index 0 and we add index 3. So sl.add nums, or remove nums of I, sl.add nums of I plus k. Let's print SL just to make sure. And this is always going to stay in sorted order, which is the power of the sorted list. So now you can see we get this subarray, but it's already in sorted order. So great, that's amazing. Now we can just run the same binary search. So B equals to bisect left in SL 0. And let's print B again. Just get rid of this one. Again, it will tell you exactly how many elements are less than 0 or negative. So here has 3 elements, all of them are less than 0, right? Here you have 2 elements that are less than 0, because you bisected left with 0, it would go here, right? If you bisected left with 0, it would go here. 0, 1, 2, 3, right? So since this is how many negative elements there are, if B is bigger than or equal to x, then we just want the x smallest. So result.append SL of B minus 1, right? So if, for example, this is valid too. So we're going to get which one? The 3 minus 1 is 2. So SL of 2 is 0, 1, 2 is negative 1, which matches. Otherwise, we can just append 0 because there are less than x. So if this number is less than x, then just append 0 because there are less than x negative numbers in that particular subarray of size k. And at the end, if we get rid of the print statements, we can go ahead and submit this and it should work. And okay. Oh, okay. Let's see what's going on here. Let's print SL. So 1, 2, we're missing something here. Okay. The boundaries of the window are messed up. This. Okay. How do we get the K windows? So yes, this is correct. Let's print B again. Print B, print SL. So, okay. So how many? 2. That's fine. How many are in here that are, so B is going to tell us how many negatives. It's bigger than or equal to K, then we want to append SL of B minus 1, right? So let's see here. If B is less than KX, we can just append that. Looks like we're doing the right thing here. So this, and this. This is 2 negatives, 3 negatives, 2 negatives. And then the X smallest here is going to be what? Is going to be so I guess if B is bigger than or equal to length of SL, then B equals to length of SL minus 1. Okay, guess not. Okay. This looks right though to me. This is bigger than or equal to X, yes. Fewer than X, yep. Maybe we are removing the right ones. B is bigger than or equal to X, then B bigger than or equal to X. Yeah, this looks correct to me. I don't know what's going on. SL. The X smallest. Oh, of X minus 1, not B. We want the X smallest, not the B smallest. Okay. X. Again, I didn't read carefully. Okay, and then when we get rid of the print statements, just because this is the number that tells us how many are smaller, that's not the one that we want. We want the X smallest. Okay, let's see here. And there we go. Passes all test cases. So not the most efficient solution. I think it's n log of n or something. N log of k. Okay. Because k is the size of the windows, but it is my own solution that I just came up with, and it has a pretty low acceptance rate. So I'm pretty happy about this. Hopefully you found this video helpful, and stay tuned for more.